everyone, welcome to today's lesson. Earlier in this chapter, we've talked about properties of radicals or square roots. So we're going to use that, and this lesson, we're going to use square roots to solve quadratic equations that's in the form of ax squared plus c equals 0. So what we're going to do here is we're going to isolate x squared by itself, and we're going to move everything else that's not x squared over to the other side. So your equation then becomes something like x squared equals d. D meaning some type of a number. So there are three different types of solutions where when d is greater than 0, like 2, 3, 4, 5, 6, it has two real solutions. So remember we talked about plus and minus signs. So we're going to have one positive and one negative solution to the equation. But when d is equal to 0, then it has only one solution, which is 0. Because if x squared is equal to 0, then all you can get is 0. When d is less than 0, x squared equals d has no real solutions. So those are the three types of solutions that you can get from x squared equals d. Let's talk about the first type of the solution. So it's going to ask you solve 3x squared minus 27 equals 0 using square roots. What we're going to do is to isolate x squared. So I am going to add 27 to both sides. When I add 27 to both sides, 3x squared equals 27. Divide 3 on both sides. Now we have x squared equals 9. That tells you that my d, 9, is greater than 0. So you'll have two solutions. So x squared equals 9 becomes x squared equals plus minus square root of 9, because we're taking a square root on both sides. Then we will get plus minus 3 as your final answer. So those solutions are 3 and negative 3. Next question. Solve x squared minus 10 equals negative 10 using square root. We're going to isolate x squared. Add 10 on both sides, you get x squared equals 0. Then you take a square root of 0, but x is 0. So there's only one solution, which one was the second concept that we talked about. Solve negative 5x squared plus 11 equals 16. I'm going to isolate x squared by subtracting 11 on both sides. So I get negative 5x squared is equal to 5. Then x squared is equal to negative 1. So here I'm going to just pause and let you know that the square of a real number cannot be negative. That's correct, right? Because you can't multiply a number times another number and get a negative, still remain a negative. So the equation has no real solutions. All right, let's go to the next example. Solve x minus 1 squared equals 25. What we're going to do is we're going to take the root, square root on both sides. That's the easiest. So get rid of the exponent. We have x minus 1 is equal to plus minus 5. And how did I get that? When I take a square root over here, this square root of 25 has two solutions, plus and minus 5. Then now we're left with x minus 1 equals plus minus 5. So really, we're saying that we're adding 1 here. So we have 1 plus minus 5, meaning x is equal to 1 plus 5, which is 6. And then x is also equal to 1 minus 5, which is negative 4. Two solutions. Let's try graphing this onto the TI-84. So I'm going to plug in x minus 1 squared in parentheses minus 25, because I have to move over the 25 to make it 0, because we're looking for zeros of the function. So those two are my x-intercepts. And that's my parabola. We're going to use second calc option to calculate the zeros of the function. Second calc. Go to number 2. It's asking you for the left bound. I need to first find my cursor. So let's move around with the arrow button to see where my cursor is. And I'm noticing that my x value is changing, negative 2, negative 3, right? So it's coming up, and I see my cursor is coming up. So that's how you can find your cursor. So then I'm going to go close as possible to my left bound of the x-intercept. I'll work on the left side first. So that's -4 point blah, blah, blah. And then after clicking left bound, enter, we're going to click the right bound, enter, and then enter again. Guess, and then your zeros of the function is -4, or 0 of the function is -4. Do that again, second calc 0, and then you have to move over to the right all the way until you see the blinker come back around. And then my left bound this time is below my 0, so below my root, because my x value is smaller than the right bound. So enter, enter, and then guess enter. 0 is 6, so x is equals to 6. So I do get 6 and -4 as your answer. Solve 4x squared minus 13 equals 15 using square roots. Round the solution to the nearest hundredths place. How do we go about doing this? Using square roots. So this is one of the ways to solve quadratic equations. I'm going to isolate, subtract 13 on both sides. 4x squared equals 28. Divide by 4 on both sides. And I would get, because I need to isolate x squared, I would get x squared is equal to 7. My d is greater than 0, so I have two solutions. Take a square root of both. I'll get x is equal to square root of 7, but I have a plus square root of 7 and then a minus square root of 7. So we have two real solutions here. And it says to round to the nearest hundredth place. So I will need to make sure that I round it correctly. Instead of leaving it as a radical, let's round it correctly. So your x is approximately plus minus 2.65. Let's plug this into the graphing calculator just to practice again and see if we get the same answer. So y equals 4x squared minus 13 equals 15, but we need to move over the 15, so you get minus 28. And then you hit graph. That's the parabola. We're going to use second calc. We already know where the zeros are. Number 2. Find the cursor. There you go. And then left bound, right bound, close as possible to the root. And then the zeros of the function is -2.65. That's one side. And then you do it again. Second calc, 0. Move it all the way to the right, below your x-intercept, close as possible. Right bound, enter, left bound, enter, enter again. 0 is equal to 2.65, so round to the nearest hundredths. So that's it. So that wraps up this question, and that's all for today. I hope this made sense. So practicing on the calculator will definitely make it easier for you in the future. So make sure you guys keep on doing the questions on the calculator and by hand. So if you have any questions, reach out to me, and good job today.